everyone, this is my next video. Today I am going to explain Leetcode question number 1523. Count odd numbers in an interval range. Given two non-negative integers low and high, return the count of odd numbers between the low and high inclusive. What they given? They given two positive integers low and high. We need to return the count of odd numbers between the low and high. We should inclusive means low and high are also included. In the example one, see, they're given low equals to 3 and I equals to 7. We need to include 3 and 7. Within the range will come 3, 4, 5, 6, 7. We need to return output. There are 3 outputs, so we are returning 3. In example 2, they given low equals to 8 and I equals to 10 and output they given 1. We can understand briefly in the whiteboard now. They given low equals to 3 and I equals to 7. The range will be 3, 4, 5, 6, 7. We need to return the odd. Here 3 is odd, 5 is odd and 7 is odd. So where output is returning 3. In example 2, they given low equals to 8 and I equals to 10. 8, 9, 10. Here where 9 is odd. So our output is only one odd is there. So we are returning 1. I will take one variable count. Starting I will be initialize it to 0. I will take I will be pointing to the low. It will travels up to the I. Okay. I'll use one condition. I percentage 2 should be not equals to 0. Then what I will do? I will increment my count plus plus. Okay. Now what I will do? I is wanting to uh, 3. No, 3 percentage 2 is not equals to 0. Where 3 is odd, so I will increment count by 1. Now my count will be 1. Now I will be pointing to 4. Next 4 percentage 2 is not equals to 0. Where 4 is even, so I will not increment my count. Now I will be pointing to 5. 5 percentage 2 should be not equals to 0. Yeah, this is odd. We will increment the count. Now I will be pointing to 6. 6 percentage 2 is not equals to 0. Where 6 is even, it will not work. Our count will be not changed. Now I value will be pointing to 7. 7 percentage 2 is not equals to 0. Yeah, where 7 is odd, we are incrementing our count plus plus. Now our count will be incremented to 3. Okay, now we completed entire all the elements traversed. We will come out of this for loop and we are returning our output as 3. See in the example 2, 8, 9, 10. For starting my I value will be pointing to 8. 8 percentage 2. It should be not equals to 0. Where 8 is even, we are not incrementing our count. Our count value will be starting 0. Will be 0. I value is pointing to 9 now. Okay. Now 9 percentage 2 should be not equals to 0. Where 9 is odd, we are incrementing our count plus plus. Our count value will be 1. Now I value pointing to 10. 10 percentage 2 should be not equals to 0. Where 10 is even, it will not work. Our count value will be 1 because we are not incrementing our count. We are returning count value is 1. This is the logic. Now we can enter into the coding part. Yeah, I declared one variable count starting initialized to 0. I taken one for loop. I started to iterate the for loop. I from low, it will be starting from low. It will travels up to I. At each iteration, I will perform this task and I will increment my I. I will check the condition. I percentage 2 should be not equals to 0. If it is odd means I will increment my count. If it is even means I will not check any condition. Just I will increment my I. Finally, after iterating all the elements, finally I will be returning count. Let's try that now. Here see, they given low equals to 3 and I equals to 7. Okay. This condition will be now 3 is less than or equals to 7. Yeah, this condition is true. Now we'll check the condition. 3 percentage 2 not equals to 0. Yeah, this condition is true. We are incrementing our count. Starting will be 0. Now increment it to 1. Now our I value will be 4. Now 4 is less than or equals to 7. Yeah, this condition is true. Now we check 4 percentage 2 should be not equals to 0. Where it is even, this condition will not work. Just we are incrementing I value. Now I value will be 5. 5 is less than or equals to 7. Yeah, this condition is true. We're checking 5 percentage 2 not equals to 0. Yeah, this condition is true. We are incrementing our count to 2. Now I value is incremented to 6. 6 is less than or equals to 7. Now check the condition. 6 percentage 2 should not be equals to 0. This condition is false because 6 is even. Okay. Now we'll not check condition. Just we are incrementing our I. Now 7 will become I. 7 is less than or equals to 7. Yeah, this condition is true. Now we check the condition. 7 percentage 2 should be not equals to 0. Yeah, where it is even, we are incrementing our count. Now our count incremented to 3. Now condition will become 8 is less than or equals to 7. Yeah, this condition is false. We'll come out of this for loop. We're returning our count. Now our count is 3. We're returning 3. We can understand the time complexity and space complexity of this logic. The time complexity is taking big of n. Here n is the number of integers in the range of low and high. We are iterating the for loop, we are iterating all the elements of n, so it is taking time of big of n. When it comes to the space complexity, it is taking big of 1 because we are not using any extra space, it takes only constant amount of space. Let's run the code. Yeah, this is accepted. Now there is another optimal solution with big of 1 TC and big of 1 SC. We can enter into that part. Yeah, in this, what I'm doing, just I'm returning the I minus low divided by 2 plus low percentage 2 is equals to 1 or operator I'm using here. I percentage 2 is equals to 1. Okay, just only one line we will getting the output. How it is going to work, we can see. First, what I will do, I will calculate my low and I is odd or even. Okay, here our low value is 3. 3 percentage 2 is equals to 1. Yeah, this is true. We are returning boolean first. Here I is 7. 7 percentage 2 is equals to 1. Yeah, this is odd. We are returning true. True means 1. Okay. 1 it is a or operator 1. Yeah, it is a 1. Okay. Now what I am doing, I will do I minus low divided by 2. Here I is 7 and low is 3 divided by 2. 7 minus 3 is 4. 4 divided by 2 is 2. I'm getting 2. Just what I will do, I will return 2 plus 1, 3. My output is 3. Okay, this is the dry run of the first example. Now I'll dry run the second example. Here low is H and I is 10. 8 percentage 2 is equals to 1. Yeah, where is 8 is even. So it will be false. But I is 10. 10 percentage 2 is equals to 1. Where 10 is even, this condition will become false. False means 0. False means 0. By using OR operator, we will get 0. Now here I is 8. Here I is 10 and low is 8. We are doing I minus low divided by 2. 10 minus 8 is 2. 2 divided by 2 is 1. Now we are adding 1 plus 0. We are getting 1. Our output is 1. Okay. Now we can understand the time complexity and space complexity of this logic. The time complexity is taking big of 1 because we are performing only constant amount of arithmetic operations. The space complexity is also taking big of 1 because we are using only constant amount of space. We can run the code. So this is the accepted solution. There another logic with TC and SC with big of 1 that I will show now. I will check here my low and I is even or odd. Okay, if low, what I did here, my low is odd means I will not increment my low plus plus. If low is even means I will increment low plus plus. If I is even means I will decrement my I. After finally I will return I minus low divided by 2 plus 1. Okay, in this logic, how it is going to work? Let's see first example. See, low is 3. Okay, I will check. 3 percentage 2 is equals to 0. Yeah, this is odd. Low will not increment. Now I will check I. Where I is here 7. 7 percentage 2 is equals to 0. No. Now our low is 3 only. I value will be 7. Now I will return. I minus here I is 7. Low is 3 divided by 2 plus 1. Here 7 minus 3 is 4. 4 divided by 2 is 2. 2 plus 1, 3. Okay. Now our output is 3. Now I will try on the second example. In this, low is H and I is 10. I'll check the condition. 8 percentage 2 is equals to 0. Yeah, this condition is true. I will increment my low plus. The range will be 8, 9, 10. Okay. Now my low value will be 9. See, where I is 10, 10 percentage 2 is equals to 0. Yeah, this condition is true. Now I will decrement my I minus. Now our I value will be 9. Now I will return I is 9 and low is also 9. divided by 2 plus 1. Then 9 minus 9 is 0. 0 divided by 2 is 0. 0 plus 1. Output is 1. Now we can understand the time complexity and space complexity of this logic. The time complexity is taking big of 1 and space complexity is also taking big of 1. Here we are using only the performing constant amount of arithmetic operation, so it is taking big of 1. Comes to the space complexity, it is taking constant amount of space. Okay, now we can run and submit the code now. Yeah, this is accepted. Now we can submit the code.